And we're live. Welcome, everybody. My name is Daniele. Thank you for joining us today. Again, my name is Daniele Bernardi. I'm the CEO of Toolhouse. And today we'll be talking about something that's top of mind for everybody, building AI agents that scale. Before we go into more details, I obviously am very excited to be having this conversation today with a very special guest, Richmond Alake, developer advocate at MongoDB. Hi, Richmond.
How you doing, Danielle? Thanks for having me on here, and I'm very excited to talk about AI agents, agentic system, and scale. And Two-House is the best place to talk about this.
It's a true pleasure. Give us something more about yourself, where you're coming from, what you do at MongoDB specifically, and we'll take it from there.
All right, that's a good point. So I'm based over in the UK. I'm on the outskirts of London. Right now, it's kind of rainy in the UK. It's that time of the year where you have the dull weather in the UK, but what I do over here at MongoDB is I communicate to our customers, to our developers, how MongoDB fits within your AI applications today. So what AI application looks like today are RAG pipeline systems and agentic systems. So I usually talk about or show people how MongoDB could help you build a reliable, scalable, performant AI application. So Daniel, you can tell me, do you want me to go into the presentation or should we save that for later?
We'll say that for just a few minutes. I wanted to give everybody just a little run of show what's going to happen today. Um, Obviously, we're going to talk about Toolhouse and MongoDB, but we're also going to talk about Toolhouse and MongoDB together to basically help developers build agentic applications faster, leveraging MongoDB Atlas. So you can basically skip the integration part and just go to Toolhouse, integrate Toolhouse, and then you'll have a MongoDB instance already provisioned for you. And we're going to show you some examples on how to do that specifically. But before, obviously, we want to hear from MongoDB and understand more about the MongoDB Atlas and how that fit into the AI ecosystem. Before we do that, as a token of appreciation for joining the webinar, you see a QR code on the top side of the screen. You can scan the QR code or go to join.toolhouse.ai, and you can get $150 worth of Toolhouse credits. So just go to join.toolhouse.ai and follow the instructions to get access to Toolhouse with the offer. And so with that, Richmond, we all know MongoDB for its flexibility. We've seen the products and the company becoming more and more relevant in the AI space. So what are you bringing to the market, and why is that important?
Okay, and the best way I communicate this point, as in why MongoDB for your AI application, is I present it in a slide. So I'm going to be sharing my screen.
Go for it.
Let's see. Disclaimer: I do have a bit of a slight cold, but can we all see my screen?
We can.
Excellent. So one thing, let's start from the top, right? So we understand AI and we understand the AI stack, and I see people talking about the AI stack from two perspectives. We have the high level, which is the application layer. Then we have the tooling layer. Then we have the compute layer. So tools like Toolhouse and MongoDB sit in that tooling layer, and this is a layer that allows your application to be performant, scalable, and reliable. And if you're thinking about companies within the compute layer, think about NVIDIA, essentially. But developers, we double click and we go into this low level view of the AI stack, where you're thinking about the programming languages, the model providers, the operational and vector database, and how you're deploying. Again, all of this is very important to how MongoDB fits within the AI story today. But when we're talking about this AI story, how did it start off, right? We had this LLM powered chatbots that came out when ChatGPT was launched. We even had some very performant chatbot before ChatGPT. But essentially, this LLM had large parametric memory, and they were able to synthesize response that were very convincing. But to get usefulness out of these chatbots, we enabled them with relevant data through systems and through system and mechanisms such as retrieval augmented generation, or RAG. But then, as the parameters within this LLMs grow larger, emergent abilities emerged. So essentially, these LLMs could now reason and decompose task into subtasks and realize tools that they were aware of within the environment to solve this subtask. So reasoning capabilities increased, and we had tool use became a thing. So now we have agentic systems where we enable this LLMs to have access to different components of our systems and use the decision and reason capabilities to decide when to access this component when they're trying to achieve a task. So that's the form factor evolution that we've been seeing over the last, let's say, 3 years or so. The AI time, things move so fast, but a lot is happening in between these form factors emerging. But the real question is, how do you retrieve relevant data? If you're building RAG or agentic system, it all comes down to data and how you're retrieving data for your systems, for your AI agents, or for your RAG pipelines. And the common ways that we've seen people retrieve data or relevant data are through text search, right? So modern data solutions or even traditional databases can give you the ability to conduct text search. And now we see more modern databases emerging that enable you to search with vector embeddings, which are just it's a numerical representation of a data object. So it allows for another way to search for data. And we've seen a lot of combination of these two methods to create a technique called hybrid search. But in MongoDB, we have all of this within one platform. So I've seen some customers building solutions where they have two databases, one for their operational, one acting as an operational database and one acting as a vector database. But you can start to see why this can create some problems, because you're going to start to have silos. There's latency in between two databases. You have to sync the data within the two databases, and it's starting to introduce complexity. MongoDB provides you a solution, all of the solution in one, through different functionalities and features. So we have MongoDB Atlas search, which offers that full text search that everyone's familiar with. And we also have the Atlas vector search, which allows you to search for search using vector embeddings. And we bring all of these functionalities and more into the MongoDB query language, which is a very familiar way to query data. It looks like JSON, it feels like JSON, and JSON is it's one of the data structure that is used across the application stack and used across different programming language. So we bring all of that familiarity, like you mentioned, Danielle, MongoDB is very familiar. We bring all of that into your data platform, into the data layer. But very quickly, just to make this whole thing very well rounded, I want to explain what Atlas search is, what vector search, and what hybrid search is. So with Atlas search, or with just normal text search, what you're doing is you're passing in a phrase or keyword into your database, and then you're searching for the documents within your database based on this keyword. And in MongoDB, we allow for queries to basically be constructed using our aggregation pipeline. So you might see a query. This is what a query looks like in MongoDB. Like I said, it looks like JSON and feels like JSON. And what we do is we return results from our database using text search, and we can return documents that match our search query, and we can display the results. The same thing, the same story for vector search. We enable you to take a phrase and then you generate your embedding, and using that embedding, you can use it as a query vector that allows you to search for documents within MongoDB. Now you can start to search for documents that are semantically similar to your query embedding, and then start to implement applications or techniques such as RAG, semantic search, or build recommendation system. And with hybrid search, you're using the best of both worlds and bringing it all into one result, and you can use a re-ranking logic, and you have one entire feature called hybrid search. And MongoDB allows you to implement all of these various form of searches and more different ways of pulling data within your AI application. And that's why we're relevant for your AI application today, yesterday, and tomorrow. So AI agents is what we're here to talk about, and agentic systems. And I always try to define AI agents, and Daniel, you probably agree with me. There's like a whole spectrum of
Exactly.
it's a spectrum of how you can define AI agents, but we can debate on this. But to me, an AI agent is essentially a computational entity that is aware of its environment. It can provide it can take an input through text, audio, or any form of input, but also has cognitive abilities to act on that input. And this is the key part. It has forms of memory, maybe short-term or long-term. Remember the keyword memory, because we're going to be hearing it a lot with MongoDB. So with AI agent, we have the ability to perceive. We also have this ability to plan. So this is that emergent capabilities of LLM that's come about from the expansion of the parameters of the neural networks within the LLM. So we also have this tool use capabilities as well, and memory. For MongoDB, we're in the tool and the memory aspects of an AI agent, of your agentic system. So we provide values and solutions to make sure that this component of your AI agent or your agentic system is the best it can be, to ensure you're building this performance AI applications that provide value to your customers. So today we're going to be talking about tools, but in this presentation, I'm going to be talking about the memory and some of how MongoDB acts as the memory provider. There's a lot going on the slide right now, but this is a very straightforward a visualization of what is an agentic system. In this section, we have this data loading process that we're familiar with in a RAG pipeline. We chunk some data, generate embedding, and we feed that into a MongoDB database that acts as your operational and vector database, giving you that normal traditional search that we're familiar with, but also this modern search of searching with vector. But within an agentic system, this whole functionality is encapsulated as a tool. So you can use this whole retriever as a tool that the AI agent is aware of and can utilize whenever it's trying to accomplish a task. But just to sort of like zoom in on that memory capability that MongoDB plays in, when I speak to developers, I try to explain to them that MongoDB is a memory provider for your RAG or your agentic systems, and it starts to click because you start to realize the importance of memory for the systems in terms of making them performant, reliable, and scalable. And I always say humans have memory, we need memory, so AI agents, they do as well. And these are just some of the ways that MongoDB the MongoDB database provides you functionalities to implement different forms of memory. So we have the knowledge base, which can be a knowledge source that you've ingested from the internet or from a PDF, and you're storing that within MongoDB and you're retrieving using any form of search mechanism. You have a profiler, which can store information of entities that your agentic system interacts with. This can be users or any external systems. So we have Toolbox, and we're going to be talking about Toolbox, and essentially we're also going to be talking about Toolhouse and tools. So I'm going to skip this step so we don't basically spoil the surprise. Then we have data store. Whenever you're working with agents or any form of system, you have a lot of data that is emerging from system log or from application interaction. You can store all of this within MongoDB and provide it or feed it into your agentic system. And then we have working memory. So this is something that we worked alongside Tavily to implement. And this is a memory that uses internet in real time, but also an existing knowledge source, which will be MongoDB, and uses those two knowledge sources in real time to provide you more relevant answers or data for your AI agents and agentic system. So data store very quickly. We have integrations with most of the tools you're using. So if you're using LangChain, Llama Index, and LangGraph, we have abstraction classes that allows you to implement these functionalities, especially the data store one, in very easy, simple, maybe 2 or 3 lines. Then we have working memory. With the Tavily integration, we're able to implement something that we are calling hybrid RAG, because we have 2 methods of retrieving memory, and we're pulling that into the system in real time, because you use Tavily to access that real-time information from the internet, and we use MongoDB to access information from our knowledge source. So I'm going to put a pause there, but MongoDB, why MongoDB for AI? Well, we have these capabilities where we're working with all the key players in the AI stack, including Toolhouse, to ensure that customers are able to build this enterprise, this scalable, performant AI application. But one thing I want you to take away is the paradigm, or some things I'm seeing a lot of people adopt, is having several databases within the AI application. So very quickly, you can see how we can start to bring in complexities within our AI infrastructure when we have multiple databases. It will be hard to maintain. You even have to start thinking about the different developer types you're hiring as well. But with MongoDB, you have this single solution, very modern database, very familiar, universal, that brings you all the capabilities and all the functionalities you need for any form factor of AI we might see today or tomorrow. So I'm going to end it there, and I will pass it over to you, Danielle.
Thank you. So that was super comprehensive, and it's super relevant. Obviously, you mentioned memory, but you also mentioned toolbox, and it really describes how tying back to the early part of what you were talking about, the form factor has evolved, and that's because obviously we all realize that AI is super useful, but to a certain extent. Like LLMs are a promising technology. AI is a promising technology, but still need to interact with the real world, needs to interact with our memories, or needs to interact with fresh data, and that sometimes does not happen. So how do we make sure that that really happens is what I suppose MongoDB is working on constantly, and obviously same way for Toolhouse, try to make agents that connect as much as possible with the real world. Perfect. By the way, I know there are listeners on and viewers on both YouTube and LinkedIn. So if you have questions or comments, feel free to drop them in comments, and we'll select the questions for later. So don't worry. We got you at the end, obviously, as you may expect, for Q&A. All right. So in this case, well, we talked about agents and how to create agents with tools and memory. I'm going to describe a little bit what Toolhouse, how Toolhouse fits into this picture. So we talked about agents, obviously, but what is an agent really? The basic form factor of an agent is really an LLM and a prompt. This prompt is specifically crafted to create some action plans. So the agent is shaped to be very skilled in one specific narrow field. That gives the agent the ability to reason on a specific domain of problems. For example, summarizing financial documents, like very, very detailed. This will help the agents create an action plan, which is really a step-by-step description of the actions the agent may take. And those actions are the kind of spark that connects the AI to the real world. And it's done in 2 ways. One is tools, and the other one is memory. And in this case, that's going to be MongoDB Atlas to store and retrieve memories. When we talk about memories, really, We can describe them as user memories if we want, and that's usually done to remember past conversations or specific user details. But we're talking about very limited data. With MongoDB Atlas, the great thing about MongoDB Atlas is that your storage needs could be scaling pretty heavily. And so if you need to create an agent that needs to summarize a large trove of financial documents, for example, there's no way all these financial documents are going to fit into what we call the context window of an agent. The context window is the ability for the agent, or for the underlying LLM, better put, to understand a specific size of text. And while LLMs are evolving and are accepting the ability to work with larger text, the larger the text, the more expensive and more time-consuming the processing becomes. And so you want to be fast and you want to be optimized. And so that's how MongoDB Atlas comes into play, because through what we call vector search, we are able to just get the proximity of a text to another part of text in a compressed numerical form. And the numerical representation is going to be much faster and cost-effective to process. And that in turn will yield a result. So this is basically the basic architecture of agents. With Toolhouse, basically, we encapsulate all these complexities into just a layer that sits above the LLMs, so above the foundational layer, but below the user's app. And so when you want to connect to MongoDB Atlas, you can just do it through Toolhouse. The way it works, it's super simple. In Toolhouse, you install tools like you install apps, and we're going to see that in just a moment. And that allows you to really have a lot of convenience done. Usually, when you need to connect something to an LLM, you need to provide a JSON description. And the JSON description varies for each of the LLMs you work with. In Toolhouse, we do that for you. The tools are also prompted for you, meaning that we already get the right description for each one of the tools we provide there. So you don't have to all of a sudden become a prompt engineer or hire one. The tools are executed in a fast and dedicated cloud to give you the best possible performance. We know that LLMs are evolving very fast, and there are a lot of modalities for which you can use those LLMs. Think on speech-to-speech applications. What if you needed to retrieve a memory because you were building a virtual assistant that could be talked through like over a phone call or through a voice app? You need to be fast, and obviously, waiting in line for a few minutes is probably not the best possible user experience. So you want to do that in a matter of seconds, if not milliseconds. And because we have an optimized cloud, we allow you to not worry anymore about the complexities of optimizing the response format or optimizing even your deployments or your infrastructure to serve fast responses. We do that for you. And because we have a tool store, think of a tool store like an app store. And in an app store, you can publish your tools and monetize your tools. And so if you're interested in publishing and distributing your tools through Toolhouse, then you can publish them and we can distribute it for you. We make them available to our large community of developers. And every time the LLM calls one of your tools, we pay per execution. And so there's a system of payouts there. So let us know. And lastly, but more importantly, Toolhouse works across any major LLM and any major framework. So that the universality of Toolhouse is basically it's secret, hidden in plain sight. This is not a new framework you need to learn. It's rather a 3 lines of code implementation that can work universally wherever you want to go. And so developers, we recognize that developers will go where the best framework is going to be, and frameworks even evolve pretty quickly. And as the ecosystem shapes itself in this fast-paced way, we can't be prescribed we can't be prescribing of a specific framework or technology. We know developers are going to switch between a framework and another framework, or and maybe walking away from a previously installed framework. That's fine to us. Wherever you want to go, Toolhouse is going to be there. And this is usually what you would do without Toolhouse. That's actually a screenshot from one of my past projects. There's a lot of boilerplate to process function calling. And that's because LLMs can hallucinate, sometimes can call a tool that does not exist. We also take care of that. That's usually what you need to do to complete all the function calling aspects. You'll probably first need to define the function, then define the JSON description with the prompt. Then you need to send the description to the LLM and then send the request. And then when the user asks the LLM for a question, like what's the current time? And that's the question that the LLM usually cannot answer, because obviously it can't have access to a real time clock. The LLM then can look at the tools that you have installed and say, okay, let me call the current time tool that I seem to be having installed. And then the developer needs to understand what's going on there, figure out if the LLM called the tool with the right name, with the right parameters, if any, and then execute the function and then send the function back to the output. With Toolhouse, we actually get rid of all these manual steps so that you can only focus on building an awesome user experience. It's that simple, and in just 3 lines of code. Okay, let's take a look at Toolhouse, actually. So I'm going to switch to my Toolhouse here. And the way it works is super simple. You have a tool store. And so behind the scenes, we have an LLM that's coded with our library. But we set and forget that implementation. Super simple. When you want to uninstall or install a tool, it's also this simple. And it works seamlessly. So I don't have to change my implementation just to add or remove one tool. And obviously here we have MongoDB Atlas that's already installed. I'm also going to reinstall the get page contents tool just to show you how this works. Perfect. So I wish I could show you more and add more complexity, but we abstracted away all the complexity so that you as a developer can focus more on building a fantastic end user experience or optimize on your use case. How do we use specifically Toolhouse with MongoDB Atlas? Because of the scalability and flexibility of MongoDB, what we can do is store a large amount of data onto MongoDB Atlas, and then ask an LLM to prepare queries to retrieve data. And the great thing about vector search is that you don't have to have a precise match or performing like keyword search. You can actually prepare queries that are phrases, and that's going more towards the field of semantic search, where you can instruct an LLM to provide a sentence and send that sentence to MongoDB Atlas through Toolhouse. What will happen is, as I showed you before, is the LLM is going to call Toolhouse, which in turn is going to call MongoDB search, get the response, and then serve it back through the LLM. And for that, we're going to show a little example of how to go to a wedding and prepare your best attire based on your past purchases. So I'm going to use the playground here. The playground allows you to as a developer, to just test out all the tools that you have installed without writing a single line of code. And that's useful to understand the behavior of tools. So I'm going to open the playground here, and it's going to load, obviously. And you'll see that we have all these installed tools, including the MongoDB memory search. The playground already gives you some prompts, but today I'm going to basically do one thing. I'm going to ask the LLM, we're using Claude behind the scenes, by the way, to prepare an outfit for me based on what I have stored in my wardrobe, my past purchases, basically. And I look at this nice shirt, which is burgundy, and I'm going to a wedding, and the color theme for this wedding is going to be fall related. So this is a good starting point. But I would like to purchase this first and understand if I have items that I purchased in the past that can go well with this color. So I'm going to go back to the playground and ask the LLM, what's on this page? Let me see. Oh, sorry, I forgot to add to paste the
web page. Yeah,
the web page itself. Yes, let me retry that. Okay. Playground is running. Examples are loading. What's on this page? There you go.
And is this going to use that web search tool, or is what tool is this using?
Exactly. That's using the web search tool. So as you see, I'll blow this up a little bit. We're adding the indication that the LLM is calling this tool to get the content of the page. And obviously, very fast, we get the response here, which was exactly the page we saw before. So second shirt in burgundy. And that's exactly what we need. Perfect. So in behind the scenes, what happened is that the LLM has requested to use this tool, brokered the request to Toolhouse, which in turn went to search the web for that page, extracted the contents, and retrieved the contents and get them back to the LLM. And the LLM could process them and prepare this answer here. Perfect. So now it's time to pack for the wedding. I'm attending a wedding, and the color theme is fall related. I stored my wardrobe in memory. So do a few searches, please, in memory to see if I have clothing items that match the color of the shirt on that web page. And obviously, the LM understood that having stored things in memory, it's time to call the MongoDB memory search. And it's going to do as many searches as possible. And as you see, the limits here are just like few results per page. By default, we return like a large pages, 100 results, but the LLM can also choose based on the prompt how many results to retrieve and how to paginate through results. Also, as you see, the query matches, and it's more of a kind of semantic sentence. It's really not a set of keywords, but just like give me burgundy clothing items in the wardrobe. And there you go. So we have a lot of actually other burgundy items that we purchased in the past, and we can pack those together. And the LLM prepared a recommendation for us. And that's obviously just a simple example, but as you see in just a few prompts, not even lines of code, you could create a people bought this, also bought that item or algorithm. And that's through MongoDB Atlas and the vector search capability more so. So one thing I want to also show you, going back to Toolhouse, is what happens behind the scenes every time there's a call like this. So we hop to the execution logs, and you'll see for each one of these calls, what happens behind. So in this case, we got the contents of the page in a way that's optimized for the LM to understand. And you see that we don't return the entire HTML page, just the text. And for the MongoDB vector memory search, The vector search becomes a plain text, a pseudo XML representation of the content and the score. And if we had more details, obviously we will return more of the details. In our example, we only had to store the category, the color, and the title of the item. We could have stored the price and other details about that clothing item. And then the score gets generated in real time for each call through obviously the embedding model that sits behind the scenes. And so you don't have to worry about implementing all this. It's all implemented for you. But not only that, the response format is optimized for the LLM you're targeting. Claude works best with XML-like format, where the separators between entities is going to be something that looks like an XML tag. This is like perfectly good XML. And other LLMs can work just on plain text or work well with JSON. We make sure that we take all these factors into consideration to make sure that you save as much tokens as possible, as many tokens as possible, and you have the best possible experience when connecting those tools into the LLM. So not a ton to worry about when it comes to the technical implementation, because we got all that sorted for you. And that is really Toolhouse in a nutshell, with that simple implementation that can unpack a much bigger use case over there. Very simply put, like we're trying to do all the work, all the plumbing work, the boilerplate work for the developers, so the developer can obviously focus on the best possible user experience there.
And one thing to mention is, you mentioned the integrations with a lot of frameworks. So I see a lot of developers using to build an agentic system, Crew AI, LangGraph, and the likes, right? So does Toolhouse have integrations within this framework, or how would it work?
Yeah, we go where the developers want to go. Developers can integrate Toolhouse with you mentioned like LangGraph, for example, Crew AI, Llama Index. But even if you didn't want to use any framework and you would just wanted to switch simply among different LLMs, you could use something like OpenRouter. And OpenRouter makes it so that every LLM you use is compatible with the OpenAI API. And obviously, Toolhouse is compatible with the OpenAI API. And so every model that supports function calling is immediately available to be integrated with Toolhouse right out of the bat. One fun thing actually is that we try and go to hackathons as much as possible to really prove the speed of development. If our metric of success in us participating to hackathons is to understand how many people win a prize when they build something on Toolhouse. So how many hackathons do we win? And like in our past hackathon, like 60% of all the people who won a prize built on Toolhouse. And that really gives you a sense of how fast it is, but also how precise and how powerful the tools there are. One thing I actually appreciate about MongoDB in particular is the speed and the flexibility in really creating something so sophisticated like vector search, and packaging that in just one click, install, and 3 lines of code is something that allows you really to focus on the best possible user experience out there.
Yeah, I think you mentioned something which is allowing developers to do what really matters and not just focusing on how to integrate these tools and do all the grunt work. And MongoDB, we have this saying, love your developers, and we really try to embody that. So when we're thinking about this agentic system, they can be very complicated, and the real work comes around making them reliable, making them scalable, and making them performant. And we need to ensure that we can help our developers to meet those criteria, right? And from the infrastructure layer, from the tooling layer. So I think that's where Toolhouse and MongoDB plays very, very nicely. And one thing I did forget to give your audience, Daniel, was a bunch of resources for them to find out more about MongoDB and the good work we do with like you folks. So Yeah, so we have MongoDB. You can register for a free account, try out all the vector search and all the search capabilities that we touched on in this webinar. We also have I think the next link I provided was the GitHub repo, which is an extensive GitHub repo that shows you how to implement different forms of RAG pipelines or agentic systems. We believe knowledge is power, and we'd love to share that. And the last one is our developer center, where we help developers, give them the best resource to essentially build these AI systems. So we're trying our best to make sure that the developers building with MongoDB or building these AI applications are going through any bottleneck as quickly as they can. And that's why we work with people like Toolhouse, because they're solving. And I was saying before we started this webinar, one of the issues we're going to see next year, one of the key things that people need to solve for next year, is for scalability of the agentic systems, right? So it's going to get very complicated when you have to manage 100 function calls, or you have to manage 100 function representing different system components. With Toolhouse, we saw it was just a quick install and uninstall. So
Nice.
that is the sell right there.
Yeah, I was already looking at the some of the questions here. So I think I have a few questions for you and for ourselves. I'll go last. So one thing I see here, what are the best use cases on MongoDB Atlas that you've seen so far? Have you like are you a fan of specific use cases or applications that you've seen?
So what I'm a fan of and what I've seen, that's a two-part question. So what use case am I a fan of? I'm a content creator. I love use cases that are optimizing content creation workflows. So all of the process in between, for example, creating a podcast, the research, the editing, the creation of content. I love use cases that really streamlines it and makes it more efficient. But what really interests me within MongoDB is looking at the variety of use cases and how advanced some of our customers are in their journey building this type of system. So what I'm seeing, I don't have one specific use case from what I'm seeing for the customer side, but for me as a content creator, I love anything that streamlines. Like I would like a tool that can take this webinar after it's finished and change it into put it into bite-sized video content or articles. That's a winning tool in my eyes.
Beautiful. All right. Yeah, obviously, one of my favorite use cases is the one I implemented, and I think I want to flesh it out a little bit more because that really explains how to go, how to deploy really apps that matters. Like in the past, to build an algorithm like that would take like patterns. It would take a lot of machine learning, and it would take a ton of data. Instead, here I actually prepared about 100 items. That is not a lot for machine learning, and then by generating embeddings, we were able to match a specific sentence to a semantic meaning, and that allowed us to just get the contents of a web page and then match it to my wardrobe. So even with very low data, you are able to provide very meaningful results out there, which to me is shocking. Like, spoiler alert, in the past I used to work with a company would basically sell those algorithms and just make it available to websites. So the usual, like, people who bought this also bought that, or people viewed that also viewed this. It required at least 2 weeks worth of training, and now it's incredible how we can do that in just a few seconds. And I think that speaks lengths to really the capabilities of AI, MongoDB, and Toolhouse. All right, I think we have more questions coming. So obviously, feel free to add those questions on the comments. Let me see. I think it's this one. Have built tools and I like to use them alongside the Toolhouse tools. Is that possible? Yes. So what you saw before, it's a tool that's built and it's made available out of the box, so you don't have to do anything. in Toolhouse, you can bring your own tools. So if you had your own version of a web search tool, or simply put, you needed to fetch information from somewhere else, you can build the function on your own code base, then pass it to Toolhouse, and with the same 3 lines of code, you can still access all the good things about Toolhouse, plus the tools that are already available. So like I said, we're all about flexibility and being as universal as possible. So if you already have tools and you have to build tools in the past, you can just bring them alongside Toolhouse. And if you are ready, we can also host them on our platform. You don't necessarily have to publish them and monetize them. We can host them for you and execute them for you, which means you can avail from the private cloud. But those tools inherently are available to you alone as a developer. So as much flexibility as we have. Amazing. I think this is going to be for maybe one or the two. Yeah, can you build a custom tool that relies on MongoDB for vector search? Well, you can actually. I think I can take this. So in Toolhouse, the implementation is already done for you, so you don't have to worry about building a custom version. However, you may want to maybe change the prompt for when the LLM should call or should not call that particular tool, including MongoDB Atlas, obviously. For example, the tool is prompted by default to retrieve personal items from the user. But maybe if I'm building an algorithm that can summarize or give us the retrieval on financial documents, you might want to be more specific that those are not just users' memory, but those are financial documents. And so we can give you that flexibility as well. It's more and more flexible, and obviously you're going to see more of this flexibility shift in our product. We know we want to be as, again, flexibility and being universal is what we strive to be, and the developers need to be having the best possible flexibility out there.
And one thing to add to this question is there's some scenarios or situations where you might want to use a combination of different search methods, right? Like vector search or text search or any other search mechanism. And with Toolhouse, you have this ability to build a custom function that Danielle mentioned. So, and I have to probably make this point, which is a lot of times when developers are building their systems, there's several lines of code. So you can actually have one implementation of a custom tool and use that within your development environment and share that across developers and make your code even more readable and more maintainable. So there are so many advantages to using things that can simplify that development process, such as Toolhouse. So yes, you can build your custom function, but they're still within Toolhouse, and you still get the advantage of accessibility and I guess the add-on of maintenance of code base, because that's very important to me as a developer. It's very important.
Yeah, absolutely. I think we have one last question. There it is. I have documents stored in English, but users can query in any language. What embedding model do you suggest?
Yeah. So there are different one. Always check informations about the embedding models that you're using. So there's usually a model card that goes with this embedding model. So some can only handle English, and some embedding models can handle different forms of language. So there isn't one. The advice I would give is your model provider will provide some information on the model, the embedding model, including the training data and the languages that they can support. Off the top of my head, I think the OpenAI can support around 40. No, actually, don't quote me on that. Go on the OpenAI documentation and see what the embedding model, the languages they support.
Yes, I can add some to that. For that specific demo I just showed you, we use the text embedding 3 small, which is pretty performant for things like clustering, which is basically what we're doing. We're basically grouping things by similarity being the color. In real life, there's also a nice hack where you can first ask the LLM to translate whatever query comes from the user into English, and then send that to the vector search, so to the embedding model, and that's underlying. That way, you basically are going to leverage the translation capability of the LLM you're using on the user's end to always compile queries in English and have better results. Obviously, if that's applicable to you. And chances are, if you need to deal with English-only data, you might want to actually perform that pre-processing translation step behind the scenes before even hitting the translation, the embedding model. So that's something that works in certain use cases. When, for example, the query is in terms of generic terms that don't really suffer from localization issues, or don't have to be precisely matching the cultural nuances of the language. So a lot of nuance and details there, but that also explains why we want to be so universal and flexible, because there are many ways to obtain very similar results. And then in the end, it's all about how do you evaluate the end results, and that obviously developers usually use like eval platforms and suites to really assess and the quality of the outputs out there. All right. I think this is about all the time we had for today. So on that note, Richmond, thank you so much, and very big fan for of the work that you're doing with MongoDB and Atlas in particular, as you saw. Thanks for your time. Again, feel free to join Toolhouse at join.toolhouse.ai and register for MongoDB one more time at mongodb.com/cloud/atlas/register. Thank you, everybody.
Thank you. Take care. Bye.
Bye.